Hi everyone, I am S Kiran. I would like to discuss about semiconductor physics. Subject is electronic devices and circuit. In this unit, I will cover some topics. The next video, I will discuss remaining topics. Okay. The following topics are types of materials like insulators, semiconductors and metals using energy band diagrams of their classification. The next topic, mobility and conductivity. Yes, before going to the subject discussion, first we can discuss something about the subject name. What is our subject name? Electronic devices and circuits. Can you think? There is a three words are there, right? The first one is device. The question is, what is device? Then electronic device. So what is electronic device? So circuit. What is circuit? Okay, first we can start with device. Okay, this is the devices, right? First we can start with device. A thing made for a particular purpose. A thing made for a particular purpose which is taking some inputs, right? Which is taking some inputs and produces desired output as per user flexibility is nothing but device. A thing made for a particular purpose which is taking some inputs and produces desired output as per user flexibility is nothing but the device. Then coming to what is electronic device? Yes, in this device we can use some electronic components. See here, like in devices we can use some electronic components like diode, transistor and op-amp, etc. So these are produces some electronic outputs. By using these components, we can make a particular device. Those devices are called electronic devices, right? So that it is especially a piece of electronic equipment. I think you can understand, right? What is electronic device? Which is using electronic components. We made a particular device. Those devices are called electronic devices, right? How to design these made of these electronic devices? Yes, simply by using circuits we can design or we can make of these electronic circuits. Now our question is, what is circuit? Yes, what is circuit? A circuit is a closed path or a rectangular path or circular path, okay, which is starts at one point and ends with another point. I will show you some random example. See here, I will show you. See here, a circuit, right? Power supply, okay, with the load RL, LED plus minus, okay. It's a some random path. Okay, if it starts one point and ends with another point is nothing but the circuit. So again I will tell you what is circuit. It is a circular line or rectangular line or closed path which starts and finishes at the same place or point. Now an electronic circuit is composed of individual electronic components, right? An electronic circuit is composed of individual electronic components such as resistors, transistors, capacitors, inductors or diodes connected by conductive wires. Here there is a new word that is called conductive, right? Wires are traces through which electric current can flow. That is nothing but circuit. A electronic circuit is composed of individual electronic components such as resistors, transistors, capacitors, inductors and diodes connected by conducting wires which electric current can flow. That is nothing but the circuit. Yes. So what is our topic? Insulators, semiconductors and metals, right? You know, in our all electronic panel boards we can use these three type of materials like insulators, semiconductors and metals, right? We will learn one by one. So what is the use of semiconductor? Whatever you have to design, whatever you have to made, any electronic component by design by using only semiconducting materials. Okay, later we can understand what is the purpose of semiconductors. So yes, coming to metals. So if you design those components, simply you can join them by their terminals. By using metals only it is possible to joining the components terminals by using metals. So what about insulator? So it stops the flow of electrons for the purpose of material which does not readily conduct electricity. So which is stops the electricity by using these insulators. So slowly you can understand these type of materials like insulators, semiconductors and metals, right? Now this is one more pattern to show the topics of first unit: semiconductor physics, insulators, semiconductors, metals, classification, mobility and conductivity, very important concepts, right? Intrinsic and extrinsic semiconductor materials. Yes. Now we can start with insulator. The first and foremost important point is a insulator is a very poor conductor of electricity. So which material is poor conductor of electricity? Those materials are called insulators. See here, I have underlined here. Which materials is the poor conductor of electricity is called insulator, right? See here, energy band diagram. This is the energy band diagram, right? So this lower band is valence band, this band is conduction band. These materials, this is the forbidden gap, right? See our insulator's forbidden gap Eg equal to 6 electron volts, 6 eV. Here very difficult to jump electrons from valence band to conduction band. I think it's impossible. That's why it is a very poor conduction. Here I mentioned why, how I will show. Very difficult to jump electrons from here to here. See here I will show from valence band to conduction band. Very difficult to jump electrons through forbidden gap because of very large forbidden gap around 6 eV, right? Okay. Now so what are the different examples for insulators? You can take diamond, plastic, rubber. These are all we can call it as a insulators. Okay, the first and main point is insulators are very poor conductors of electricity is called insulator. See here energy band diagram. Next, energy gap 6 eV and right thumb theory. In my description I have provided notes, just you go through it, you can understand. No need to read all those things. Okay, I will show some classification diagram of this total 3 materials like insulators, semiconductors and metals. Just one more point, you have to mention number of free electrons in insulators. That is very important point. I will show you. So before going to the classification of materials, first you concentrate on energy band diagram. Yes, see here, this is the energy band diagram. The first one is insulators. See here, the energy gap is 6 eV. You have to draw like this only. That's why I haven't copied this one. This is the insulator energy band diagram. The lower one is valence band, upper band is conduction band. The electron gap is equal Eg is equal to 6 eV. The middle band is forbidden band, right? Okay. The second B is insulator energy band diagram. You see here, in valency band there is small holes, right? In conduction band there is small free electron. Is somewhat easy to jump from valence band to conduction band. See here, somewhat easy, just you can give the power supply or electric field, right? Now this is the metals. In this metal the valence band and the conduction band is overlapping. So these 3 points are very important, and diagrams and this forbidden band gap, energy gap. For insulators 6 eV, right? Semiconductors 1 eV, that is called energy forbidden band energy gap. This metals overlapping. Okay, these 3 points are very important. Now coming to three unique differences of these 3 materials. See here, a very poor conductor of electricity is called insulator, right? An excellent conductor is called metal. A material whose conductivity lies between these two extremes is called semiconductor. Again, I will tell you, a poor conductor is called insulator. Excellent conductor is called metal, which is having between these extremes the property of the property of metal, the property of insulator is lies between these two extremes is nothing but the semiconductor. Okay, a material may be classified as one of these 3 depending upon the energy band diagrams. So based on energy band diagrams, we can classify these 3 materials. That's why you have to concentrate on these energy band diagrams. Yes, already I informed to you, there is a number of electrons. Roughly in insulator, just you can underline, very important point, 10 to the power of 7 electrons per meter cube. Right? In insulators, 10 to the power of 7 electrons per meter cube, free electrons are available. Right? Good. Next, we will enter into the metals. Right? Before going to metals, this is the concept. Right? This is some theory part. Just you can download in this material. Everything is provided. Right? Next. Okay. What here I am discussed. So, first of all, insulators. Next, semiconductors, then next metals. Right? Yes. How we can start here? Insulators, semiconductors and metals. Now we will start with, already we discussed about the insulator. The energy gap is 6 eV. It's very poor conductivity. Right? The number of electrons is equal to 10 to the power of 7 electrons per meter cube. Now energy gap 6 eV. Now semiconductor. Yes. A semiconductor, just now I have discussed about semiconductor. A semiconductor material whose conductivity lies between these two extremes is a semiconductor. Okay, semiconductor. Now, a substance for which the width of the forbidden energy gap are relatively very small. The energy band gap EZ is equal to 1 eV. So somewhat easy to jump from here to here in semiconductors. Right? This is the energy band diagram for semiconductors. Based on semiconductors classified into 2 categories. One is intrinsic semiconductor and extrinsic semiconductor. Okay, intrinsic semiconductor is also called pure semiconductor. Right? Extrinsic semiconductor is also called impure semiconductor. Right? Again I will tell you, semiconductor classified into 2 categories, intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductor is also called pure semiconductor. Extrinsic semiconductor is also called impure semiconductor. Pure semiconductor, to adding some impurities, it's converted into a impure semiconductor. Very valid point. That concept is nothing but doping. Okay, later we can concentrate what is doping and types of doping. Right? This is the semiconductor. Okay, then what about the number of electrons presented in the semiconductor? See here, I will show. Right? In the semiconductor, the number of free electrons, there is a range between there is a range between what that is called metals and insulated. See here, there is a lies between, I have to underline here, the number of electrons between 10 to the power of 7 and 10 to the power of 28 electrons per meter cube. Right? These are the electrons are. What are the different examples of semiconductor? Silicon, germanium. These are all the some examples of the some semiconducting materials, right? These are all the some types of the semiconducting materials. See, once again I will show the energy band diagram. You can see here, you can understand this is the semiconductor energy band diagram. The electron gap is equal to 1 eV, right? Now then what about a metal? Yes, just now I informed to you a metal excellent conductor, right? The metal excellent conductor, forbidden gap and energy band, forbidden gap and conduction band is overlapping. So I think the number of, there is no energy gap between the valence band and conduction band in metals. The number of free electrons is equal to 10 to the power of 28 electrons per meter cube, right? See here in the metal, the band, this is the energy band diagram overlapped here, right? Next, okay. So what about in this materials, how we can deliberate about conductivity and mobility, right? In this description I have provided my notes. Just you go through it, you can understand about somewhat deep explanation, right? Now so what is our next topic? Mobility and conductivity, right? So what is mobility? So I think mobility, the word itself, it's defined the ability to move freely and easily. You know, one point, it's free very easily. So to mobility, to free, move freely and easily. So it's nothing but the mobility. So how we can define in a mathematical way? See here, this is Vd is equal to mu E bar. So mu here stands for mobility. E means here electric field. Vd means drift velocity, right? First we can concentrate what is mobility. Okay, just now I just now I said it's the ability to move freely and easily. For example, you, when a constant electric field here, when a constant electric field E bar is applied to a metal, so what about electrons? Electrons will be accelerated. See here, electrons will be accelerated and the velocity would increase indefinitely with the time. So I will tell you, let us take one metal. You have applied some electric field in E bar. In that metal, it's having some electrons. Those electrons would be accelerated with a velocity. However, because of collisions of electrons, electrons lose energy in a steady state condition, right? No, those electrons having some velocity due to collisions, that electrons, due to that electrons having some velocity, that velocity is nothing but the drift velocity. How it will get? Only because of applying some electric field. Okay, because of electric field in that metal trying to move towards to the power supply or due to collisions. Okay, just you can apply electric field, the electrons are trying to move or freely and easily applying the electric field. Okay, so electrons are trying to move very freely, so it nothing but it is a mobility. Okay, so that electrons having some velocity, so that velocity is nothing but the drift velocity. Okay, applying the electric field, electrons are trying to move with some drifted velocity. Those electrons moving or freely, that concept is nothing but the mobility. Okay, that's why we can derive one expression, that is Vd equal to mu E bar. Here Vd is nothing but what? Vd is drift velocity, mu is mobility, E bar means electric field. Due to applying electric field, electrons are trying to move towards the supply, towards the load. So free or move the electrons due to the velocity. That concept is nothing but the mobility. Now see here, drift velocity is proportional to the electric field. Then mu, mobility of the electron. So the units for mobility is equal to meter square per volt second. See here, very important. What is the units for mobility? Meters per volt second, right? Now then one more concept, that is called conductivity. So what is conductivity? So here I have discussed one main point. A poor conductor of electricity is called insulator. An excellent conductor is called a metal, and material whose conductivity is lies between these two extremes is called semiconductor. So conductivity. So what is the topic? Conductor, conductivity. So conductivity is nothing but the property, right? So what is conductivity? So first, before going to the conductivity, you have to concentrate one equation, that is J is equal to sigma E bar. Here sigma can be treated as a conductivity. How it will be get J is equal to sigma E bar? The first, so J is it's a current density. Okay, due to the applied field, a steady state drift velocity has been superimposed upon the random thermal motion of the electrons. So directed flow of electrons constitutes current. If the concentration of electrons n, the current density ampere per square meter. Now what is J? J is equal to I by A. I means current, A means area. So based on that equation, we can write J is equal to NQVD, right? What is our J? J equal to NQVD. You know already VD means some drift velocity. VD we can write mu E bar. Now, so this NQ mu we can call it as a sigma. So sigma is the conductivity of the metal. So what is units for conductivity? See here, per ohm meter. See here, per ohm meter, or ohm meter whole to the power of -1. This is the unit for conductivity. Meter square volt second. This is the unit for mobility. Okay, these 2 points are important, these 2 equations are important, right? So what is conductivity? Conductivity, the equation is J equal to sigma E bar. Sigma is nothing but conductivity, units is per ohm meter. So mu means mobility, to move freely and easily. VD is equal to mu E bar, right? Okay, now coming to the some definition. You know, just here J is equal to sigma E bar. Then what about sigma? Sigma is equal to J E bar. Okay, sigma equal to J by E bar. But based on this expression, we can define one definition. Okay, sigma is the conductivity of the metal. For a good conductor, the approximately 10 to the power of 28 electrons, approximately 10 to the power of 28 electrons per meter cube of the given metal, okay, or given conducting material or conductor. Okay, now coming to definition, the degree to which a specified material conducts electricity calculated, see here J is equal to sigma E bar. So sigma is calculated the current density. Here J equal to current density. See here, I will write the equation. See here, current J is equal to sigma E bar. So what about sigma here? So sigma equal to J by E bar. Okay, so J equal to current density, E bar is equal to electric field, sigma equal to conductivity. So the ratio of the current density in the material to the electric field which causes the flow of current, that is nothing but the conductivity. In the metal, there is 10 to the power of 28 free electrons are available. I think you people can understand a clear idea about mobility and conductivity. If you ask a 2 marks question for mobility, simply you can write mobility is nothing but it's move freely and easily of the given material. the expression is Vd is equal to mu E bar. Write some theory part, right? Then conductivity is nothing but the degree of which specified a material conducts electricity, calculated as the ratio of current density in the material to the electric field, which causes the flow of electron. So what is the expression? J bar equal to sigma E bar, sigma equal to J bar by E bar. J bar means current density, E bar means electric field. Okay, the next video I will discuss remaining topics. Thank you so much. Thank you.